Good morning, everyone. My name's Alok. I'm the Science and Tech editor at the Economist newspaper in London. Thank you all for coming. It's a packed audience, I can see. Next year, this will happen in the other bigger room, I'm sure. Now, you're all here, and I'm sure you're desperate to know what I think about AI, right? You're desperate to know what I think the most important thing that AI is ever going to do is. And despite all the conversations about productivity and writing emails properly and all of that other stuff that AI is meant to be able to do, videos, et cetera, for me, the most important thing AI can do, and hopefully will do, is accelerate scientific discovery. I mean, fundamentally, that's it. If it does nothing else, that is the most important thing that AI can do. And I hope that many of you will agree with me by the end of this conversation. I'm joined today by Anna Koivuniemi, who is the head of Google DeepMind's Impact Accelerator. What is it accelerating? Hopefully scientific discovery. And so I'm going to ask Anna how Google DeepMind is thinking about scientific discovery and how it aims to accelerate all of this. Anna, it's a great pleasure to talk to you. If I was stuck in an elevator with you, as all Silicon Valley people talk about, or in my language, a lift, if I was stuck in a lift with you, what is the lift/elevator pitch for what the Impact Accelerator does?
Thank you. And it's an honor to be here, and thank you all for coming. I'm very pleased that there is an interest and open discussion on how to use AI to accelerate science. And now, Google DeepMind, and this is a bit longer than an elevator pitch, so I hope we're going to very high up.
It's a long elevator, go on.
The Google DeepMind's mission is build AI responsibly to benefit humanity. And my team especially is looking at what technologies, what models we have in-house and expertise, and how we can bring them to the world to maximize the impact for humanity.
Okay, that was a good elevator pitch. So I'd like to just start with an example of something that you have done, which I think will help us to understand how your team works. So everyone in this room pretty much will probably have heard of AlphaFold.
Has everybody?
Has everyone heard of AlphaFold? Who hasn't heard of AlphaFold?
Oh, wow.
Okay, well, maybe it's a good line to explain what AlphaFold is. Maybe I can say AlphaFold, which is a model. There are several versions of the model that predict the structures, 3D structures of proteins from the sequence of amino acids. It's a long-standing problem in structural biology, which has largely been solved. AlphaFold helped Demis Hassabis and John Jumper, the creators at DeepMind, win the Nobel Prize in Chemistry last year. You should be saying this stuff. But anyway, AlphaFold was rolled out to scientists around the world. And I want to use that as an example of what your team does. How do you make something like AlphaFold available to the scientific community, and how has it been used?
Yeah. I'm pleased to be an audience who knows AlphaFold. I was this week earlier in Rome, and 20% of the audience knew AlphaFold. It was a food-specific audience, so great. And you did a fantastic job of explaining what it is. Now, when AlphaFold started to develop, or when we got the research project, already then my team was involved. And my team was thinking about, what can this technology actually do? And we were at that moment not really sure what kind of research it could or science it could advance. We know that it is an important problem. But actually my team was from early on thinking about, how do we make sure that this gets hands to the scientist? And luckily, we were lucky to work with the EMBL-EBI, the European Microbiology Lab, who already had that access and who was a respected party to distribute the information. So we worked together to make sure that both Google was comfortable, but also EMBL was on board to what is the format to distribute these structures. And we started by distributing 200 million structures, that's roughly known proteins in the world, to the research scientist. In the past, it took 1 to 3 years, maybe sometimes longer. I have one structural biologist in my team who never found the structure of his protein. So it took 1 to 3 years for single protein for one PhD to figure out. So we distributed 200 million proteins to the scientists of the world. And then later on, we also developed a platform called Server, which enhanced the capabilities of understanding the interactions between protein, RNA, and small molecules. Now, this platform has been used today by roughly 3.5 million scientists in the world. And the Server has basically folded new combination of 8 million roughly today. So there's a huge amount of people who are using and seeing this beneficial. Every quarter, my team is looking where are the scientists using that in order to understand are there gaps of people who could benefit this but are not today benefit, like in Global South, as we heard earlier today, or like in specific areas like food, why I was talking this week on the Food and Agriculture Forum. And I have to say that for me, it's like I told you that I'm reading sometimes evenings what these technologies do, and it's always like a small Christmas when I read about them. And examples I can share with you today, that this is one of a favorite example actually of our marketing team, is that there is a research group across Norway and Portugal. I think it's led by Vilde Leipart, who as of 2021 has researched bees. And now I think everybody in this room knows that bees are important because they pollinate. And they are in danger because they are basically diseases that are attacking them. And they've been using AlphaFold to understand the immunity protein called vitellogenin. And these are the difficult names, Maria, that I need to help on pronouncing today. And based on the work they have done, they're now breeding bees that are actually more immune to the dangers the bees have today. And I can talk the whole day of these kind of examples. Maybe another one is the teams that are working working with the Chagas disease, which is killing or infecting 6 million people in Latin America today, more than actually any of the parasite diseases, including malaria. And it's a very complex disease because first you have basically a very mild infection period, and then you have a longer chronic period, which can cause to 20 to 30% of these people serious lifelong issues. And there are 2 treatments, but they are not so helpful. So this research team used AlphaFold and experimental work to identify 30,000 compounds that could help to actually attacking or supporting these parasites. And based on the work, they identified 2 existing FDA-approved drugs that could be helpful for these diseases. So those kind of advancement, how scientists are using technologies like AlphaFold, are really the example how AI can accelerate science.
So at the base of this is understanding that proteins, which are the sort of structures of all life and the way that cells communicate with each other and all of this, understanding the 3-dimensional structure of proteins is incredibly important to understanding processes, to understanding disease targets, working out how these proteins go wrong. It is important to finding out how diseases function, etc. And so this is why AlphaFold was so important, because it allowed scientists to very quickly get to the structure of a protein to then do the next bit of the work. Because understanding the structure is the first step, then you have to do something with that structure, which normally might have taken a decade or more. So I'm curious how you take your models and the stuff that comes out of them and actually engage the community. You've talked about publishing lots of structures of proteins, and people will come and use them. But then how do you go to places how do you identify people to sort of engage with? Do you engage with them, or do you wait for them to come to you? Do you think to yourself, we've got a model that can be useful for you over here in the materials, or weather forecasting, or whatever else? Or do you think, here are our models, scientists come to us? Which way does it go?
It goes both ways. We have a lot of technologies. So AlphaFold is one example, and I'm talking often about AlphaFold because it has been longest out there, and it has such a huge application areas.
It's probably the most famous one, though.
It's more easy because people like audiences, advanced audiences like this understand it. But of course, we have models that are more in a testing phase, like what we have in AlphaProteo, which is protein function design and protein design. We have AlphaGenome, which came out, which is our genomic model. For those situations, we often look parties to even develop the model, but mostly to test it and validate them.
So you're bringing academics in while you're making the model?
Yes. And during basically when we're testing the model, how it performs in different environments. Often the needs of who academics we are approaching are related to people who we know are very advanced in these fields or very good in these fields, or people who are researching topics that we are interested to test the models with, or people who are researching the top of what we call like global challenges that we want to address. So we are proactively approaching certain institutions to do the trusted testing program. I think a good example of this is our cyclone model. So we have very good weather models on 15 days, and we figured out, actually my team was looking how to build them for benefiting humanity. And we identified with Gemini 350 cases we could use them, and one of them was actually extreme weather. Now, our general weather next models are really good of predicting wind, and we thought, well, hurricanes are extreme weather, and there is a collaboration. There we literally looked at the 7 agencies who are doing hurricane and cyclone prediction and partnered with them during the development to test and develop the methods. But we have also a lot of inbound reaches, so people who have a problem, who have a challenge, they think our models, or sometimes they think we can help, are reaching out to us and seeking for collaboration.
Did you just say that you asked Gemini what the challenges are going to be? So I could just ask Gemini on my phone, what are the main scientific challenges I need to address in the next 10 years? And that's, or do you have a better version of Gemini than I do?
It requires a bit more better prompting.
Better prompt engineering.
But absolutely, we use Gemini actually to find opportunities.
But it's interesting to know. I'll use it for my own purposes in that case. So you've talked about a weather model which you then have, and then you can use for different purposes. But just talk to me a bit more about the identifying problems and then working with organizations to build models for those purposes.
Yeah.
And there's an example you give with the Wellcome Trust you're working with.
So the Wellcome Trust we're working with, so the general models like Gemini, these LLMs, large LLMs, can be very beneficial, but you need to think about carefully where do you deploy them. We got a huge amount of inbounds on entities and basically mostly non-profit who wanted to address the mental health challenge with using LLMs as a chatbots. We found that that's basically ethically risky to use these models to the most vulnerable part of the population. And these models, we wanted to approach it in a more responsible way. And Wellcome was starting a research program where they ask actually applications to researchers who want to do a research on how do you use LLMs to address mental health crises. So we partnered with Wellcome to do a few hackathons, what could be the ideas, but now we are in a process that we have now actually certain number of applicants that have been chosen to work together to a real final proposal, and in next spring Wellcome will choose the ones which they will be funding, and we will be supporting them with the access to our Gemini but also expertise of how can you use LLMs on their specific research area.
And is the intention there to have a product or a version of Gemini that would be able to be responsibly used for things like in mental health conditions, or treating them or understanding them better?
No, this is basically the purpose is to advance mental health research with the LLM. So we want to only help those researchers to find solutions how AI and LLM can help in mental health.
Okay, we've talked so far about models being used to accelerate different elements of a researcher's journey, right? They're looking for something, whether it's a protein function or whether they're trying to predict the weather or something, as part of a piece of research which they have created, they've thought up the hypothesis for, and they're going off to do that. And this is a tool for speeding up their research. Do you think that there's going to be a point where there's the models themselves in the future will also help to generate hypotheses or identify gaps in research which people should be researching, things that the human scientist hasn't thought of?
Yeah, and we had an interesting discussion indeed last night also that how can we, of course, AI can be a tool of productivity, but AI can also accelerate the science enormously, like in the case of AlphaFold. Hundreds of years of research would have gone into that. But what can we do to identify AI to more identify new solutions or even new problems?
Or new hypotheses even.
Or new hypotheses. Yeah. We are now testing a solution that is built on Gemini, but very much fine-tuned and worked around it, basically to identify gaps on biomedical research and generate new hypotheses. That's called Co-Scientist. Some of you might have read it because it went virally very, very broadly up there. But we're still testing how well it can perform. And one of the test cases was AMR. In general, my team has looked into what AI can do in AMR, antimicrobial resistant, for the people who don't know the acronym. And we have been looking at advancing research on that area. And together with the Fleming Institute, where there was Jose Benades researching this topic, and they were trying to understand how it's called phages are entering to viruses and taking them over and then getting into the bacteria cells and making them resistant. And they have, of course, a research team that is very, very talented and has been looking at this area probably of years or tens of years. And they looked at different papers and different researches to try to develop a hypothesis how this happens. And they had an answer, but we said, could we test co-scientists in that context? And we said, don't give us your answer. And we used the co-scientists, filling them with the papers and with the content they were looking into. And within the day, the co-scientists came up with the same hypothesis that Jose's team has done. There's a fantastic video in YouTube. The ones who are interested with Jose is saying, like, you read my emails. You got into my computer. You're reading my mind. Because he couldn't believe that actually in a such short time co-scientists could do that. So there is a definitely outlook that these AI systems could help to develop in new hypotheses, at least in specific areas. And that's what we're testing now.
So you're testing that now. Has it been into other fields as well, beyond biology and medicine?
We're looking at the applicability currently.
Yeah. And I guess the question there also is, do scientists want this at this moment in time? I mean, experimentally they might, but have you had feedback around maybe the scientists you're working with there? Do scientists want a research partner that will come up with ideas for them?
I think it depends on individual scientists and probably audience. It's better to answer. Later. But I think that in case of Jose, at least, when my team discussed with Jose, he was saying that there is so much information out there. As a human, it is hard to just grasp everything. And the pattern recognition, of course, when humans are best, they're probably the best to recognize patterns and identify those hypotheses. But can we be always at the best? Do we always have the best team around, the right people around us? And therefore, taking that risk of error, risk of missing something out of the system by enhancing human capability with the tools like that is something they were at least.
Okay, given these, so we've got the tools that are already available, AlphaFold, etc., the ones that may be coming in the future, co-scientist, to do different parts of the research and development journey that scientists go on. I wonder if you could just take a step back and just give us a sense of which fields of scientific research are most amenable to this, at least from the point of view of the work you're doing. Which fields are going to be most impacted by this? I suppose molecular and structural biology is one, but what are the other ones that you see most potential for?
This is a topic, again, I can talk hours of, but I think that what I'm excited when I look at the development of our models, at least, so my answer is definitely biased of what we have done, is indeed structural biology, is genomics, what's coming out there. It's definitely climate and weather. It's energy, the fusion model we have to predict the plasma, controlling plasma in a tokamak is interesting, and hopefully we can get advancement there. It's materials discovery. We have a model called GNOME who identified new opportunities of new materials, including, for example, lithium ion, 500 new combination of lithium ion, which could be interesting for battery development. And it's areas like mathematics and physics. I mentioned to you the interesting paper we came up with 3 weeks ago about fluid dynamics, which is hundreds years old problem, and then how to basically mathematically describe the moment there is a blow up, when basically it becomes infinitely unstable. And we just did work with AI combined with these physical models, but with the AI precision found the whole families of new formulation to predict that blow up model. So I think the answer is there's very many areas.
I wonder if there's going to be an area that isn't affected. All of these areas, of course, are very data intensive as well, so it's amenable to that immediately. And I suppose there's the subjects which don't have huge amounts of data will start collecting that data in order to maximize their use of these models in the future. I'm going to come to the audience for questions in a moment. So if you've got any questions, please put your hands up and I'll collect a few. But before I do, and wherever the microphones are, if you could go to some of them at least. One more question for you. All of this we've talked about critically depends, all of the effective use of AI in science critically depends on the AI making predictions and producing results that are accurate, right? So how do you assure scientists that what is coming out of these models, what is what they're doing is explainable, understandable, accurate, validated, all of those words.
Yeah, we discussed today indeed that how do we teach people that actually there is still hallucination, unfortunately. Well, I think we could have a whole philosophical discussion of accuracy of the science, but this is a very important part when we look at the interpretation of the results. For example, when we took the AlphaFold results to the world, we realized that there is a gap of structural microbiology, which in typical are extremely talented, mathematically advanced people, their ability to interpret the results. For example, how confident we are that some structure is a sure structure. And if you look at now the pictures of AlphaFold structures, this beautiful protein three-dimensional structures, you can see colors. And we came up with those colors to indicate the certainty that that structure is correct in order to educate and make it clear for the audiences interpreting that of the uncertainty of the specificity of the answer. So I think that it's very important that we only don't do it in AI systems, but we also think about the interpretation of the audiences who use these systems, of the accuracy of the output.
Is it always a bad thing to have a hallucinating result in these fields? Hallucinations are not necessarily a bad thing, are they?
No, and I have to remind everybody that if you tried to use Gemini, which is our LLM model, half a year ago versus today, the difference is huge. So these models are developing huge, and it's almost like when somebody identifies the issue, like there was, I think half a year ago, it couldn't calculate the number of Ks in the word ketchup. And then the researchers, they go hunting to solve that. So all of these issues are reduced month by month, week by week. So in that sense, hallucination, we've come a long way, but we're not yet there that we can basically put human lives on depending on the output. So you need to be aware that these hallucinations happened, although there's hard work to improve them. And like you said, in some cases, if you want to ideate or be creative, maybe some hallucination in those use cases need to be enabled.
Well, you say hallucination, some people say creativity. They're similar things, right? Questions from the audience, please. We've got a few minutes for questions. So why don't we start at the back? There's a question there and another one there. Let's just tell us your name, please, as well.
Okay, I'll start. Robin Lovell Badge, Francis Crick Institute. Two sort of related questions. I mentioned this earlier about there is little or no regulation in the field of AI, so that's should there be? And then are there areas where you shouldn't use AI to try and delve into a problem? Are there areas which you should avoid?
Thank you, Robin. That was very good questions. I'll collect one more just here on the side, maybe one down here as well.
Yeah. François Rivasso, I represent WIPO for the time being. I was also French ambassador here, WIPO, World Intellectual Property Organization. On one specific domain you have not alluded to, but which I know is a subject of many speculations, is cybersecurity. Do you think what could AI do for cybersecurity? Thank you.
And just one final one here, right at the front, and then we'll come to you. You can answer these together, please.
Hello, thank you very much for this exchange. I'm Kayla Yalom from Swissnex, and my question is regarding this co-scientist that you had mentioned. We know that in scientific research, diversity of thought is very important. And so how are you addressing this issue of maybe AI having all of the same influences in its training sets? And how are you offsetting that and making sure that there's still diversity of thought and that we're not silencing different outlooks and experiences in our research?
Thank you very much for that question. So three areas there. What do you do about regulation? And are there places not to use AI? Cybersecurity. And also, how do we make sure that the co-scientist or whatever version of that model comes out in the future is as diverse in its thoughts as possible, which is a general problem for AI.
Thank you. Start with the regulation. This is a technology that develops extremely fast, and it's going to have a kind of capabilities we don't see even today. So we think that it's extremely important that we regulate it for safe use and, for example, to prevent bad actors to using it in a wrong place. However, that regulation needs to make sure that it balances the ability to innovate safely and responsibly. So I think that those regulation discussions needs to be happening involving users, involving regulators, involving parties like us who are technology experts to make sure that we actually safeguardly develop and deploy this technology in the world. And relating areas that AI cannot be used, like I'm trying to come up with the example, I'm sure there is a lot. I think that the point is that how do you make sure that it can be, the benefits are, that there is no harms caused? And in every model that what we develop, for example, in the beginning of the idea, when there's idea what that model can do, we are involving our ethical research department to think about, they are looking at first indeed how the data can be biased, how the data can be flawed, but also what could be the potential risk of deploying this into the world. So I can give you an example of this weather modeling. When we thought about actually taking it to the cyclones, we had a long of discussion. Is there potential malusage that this can cause? Or when we put AlphaFold out there, we actually talked to 50 different experts because we did not have all the information in-house to understand, is there any risks of harmful use or harmful behavior. So I think that I cannot give you a concrete example of what should immediately not get used, but every use should go through this very thoughtful ethical discussion. What are potential downsides of putting open science out there? The second part was cybersecurity. Absolutely very, very relevant question and thoughtfulness, because I think there is a research or thought that AI in the hands of bad actors can enhance cybersecurity attack, making them much more cheaper and making them much more easier to produce. And there's some indications maybe on that already. Therefore, we need to think about how to use it to defend it. And I just think that last week we announced a Code Mender, I think it's called, which is a program that automatically identifies in the code risky areas or vulnerable areas and guides to a coder of correct them without taking the action, but guides the areas that might be vulnerable to the cyber attacks. And this is cyber is an area where we have a special research team to look at that, how we can use AI to defend the cyber attacks and develop also their own practices and protocols to make sure that the bad actors cannot use it in a bad way.
And then the diversity of
the diversity of co-scientists, I think that there is also a question of diversity, the research team, and maybe to answer that first. We've been already years actually investing to try to diversify the people who are developing AI by funding scholarships in the low resource environment and helping low resource students to enter to AI. But also we're looking into, so there's also the human aspects of biases. But in our models, this ethical team, what I said, is very thoughtfully very granularly looking at the data bias and looking at biases, potential, how to mitigate the biases in the data and in the system itself, which are the data it needs to emphasize or not. And now I'm not saying they are perfect, but humans are not also perfect. And together as a communities, we need to work to make sure that those models have the data available in order to make sure that they can do diverse recommendations.
Now, we've only got 1.5 minutes left, and I'm going to take the opportunity to ask the question myself, because I feel like I've not asked enough.
I was thinking about, there's a very young gentleman with the question, which I think that
you had a question?
The very young gentleman there.
Why don't we get that question, and then I'm going to also ask my question. Where are you? Oh, please just tell us who you are and what your question is.
Hi, I'm Renzo Lucida. I'm with the Villar Institute, and I'm a high school student here. My question was about the energy and resource costs of AI, and associated with accelerating scientific discovery with AI, how can we minimize the problems with that and the costs of energy and resources?
Very good question.
Thank you for asking that
question. I'm going to append my question to the end of it, if you don't mind, which is, please answer that question as well. But I want to know, for the people here, and also for the wider scientific community listening, how do they get to work with your group? How do they approach you? And what are the sort of pitfalls? What are things you're not looking for, basically, as well?
Thank you. And thank you for the question. It's a very important discussion to have. And I can guarantee you that we're working very hard, both on sourcing our energies in a sustainable way, but also working on efficiencies of our hardware, but also how do we train the models to reduce the environmental burden it has. So what we also need to remember that some of these models are actually positive for the environment. In terms of, if you look at the AlphaFold or weather, they required a lot of compute and a lot of actually energy incentive equipment to solve the problem itself. So in some cases, and that might be the minority of cases, but especially in scientific cases, some of these solutions are actually positive for environment versus old methods. On top of that, there are a lot of AI solutions that can actually help us to achieve the positive environmental impact. I'm mentioning one which my team is researching, which is called power optimization. So when the energy systems are supplying power and matching it to demand, it's actually a very, very complex problem. It's extremely complex problem. And it's to date done on perfect ways. My team is researching. We don't have a solution yet. We have a theoretical paper out there called Kanos, which basically tries to make this matching of supply and demand more efficient and more precise so that we don't waste especially the renewable energies, which are harder to predict, and that we actually maximize the safety and availability of energy. So we need to continue to work on the efficiency of these models, but also application them in energy positive cases. And to your questions, how to contact with us, I would say that my primary advice was to do world-class research, because that and not only in the areas of what we've discussed today, but also we need much more research in an area of ethics, responsibility, and also economic models of the future. So we're firstly often when we develop models, we're looking at those basically institutions that do world-class results. And then my team is looking at institutions that are trying to address problems that are not necessarily, that there is systematic barriers like lack of data or lack of skills, or basically problems that are benefiting the whole humanity, but there is no financial incentive to fully got into them, like AMR, that we could solve. So working on the right problems is the first guidance. The second thing is that we can always reach out to us. To your question, when not to reach out to us, don't reach out to us if it's not an AI problem. AI is not a silver bullet. It's not like sometimes statistical models are really good. So don't reach us if you have not about if it's an AI problem. If there's no data, we still get like 30% reach outs with the problems that there's no data, or if there's no evaluations, way to train the models towards a goal. And also if there is, like we tend to like the root node problems, the problems like AlphaFold or weather, when you solve them, they can actually influence a lot of different areas.
Anna, thank you very much for all of that. It's been fascinating. Can I please have a round of applause for Anna?
Thank you.